So as we continue forward, remember we said we're always going to make comparisons to that of the amphibians. And the reason that would, why would we, in your mind, why would we continually make comparisons to that of the amphibians? Why not the birds? We're further than this, I know. Because one of the things we'd always talk about when we're referring to the reptiles, we would say, okay, there's something moving along the ground. We know that is a reptile. Why? Aren't we past this? Oh, we're not. Oh, I'm sorry. I thought we were well past this. Okay. Maybe this is where we pick up then. Okay. So one of the things that okay, what just happened? We have gremlins running around here or what? Why does this have to be so darn difficult? Okay. So I do know we had talked about this, okay? What happens in humans is this has to be fixed, okay? This incomplete separation. We're talking about a 4-chambered heart here now, and I guess let me back up. It may not have to be fixed if it's a big enough of a hole or septal defect between the two chambers, then it probably does. But why is it that these animals can get by with this? Not because the blood's not mixing, which it doesn't, but if we had a hole in our heart, I mean, some of the blood will mix with this, but in humans' case, why does that have to be patched up, do you think? It has to deal with endothermic and endothermic. So what's the difference between, did I just say the same thing twice? I think I said endothermic twice, didn't I? It has the difference between ectothermic and endothermic. So you have to know what is the difference between those two. Which one of those means producing heat within? That's right. Being endothermic means you're warm-blooded. Being ectothermic, like amphibians and reptiles, means they're, of course, cold-blooded. So why is it, going back to the central question, if this blood mixes, it's still okay? Because what's the main difference between, besides being warm and cold-blooded? What does that mean as far as metabolism is concerned? Which one's faster? Much faster. The metabolism has to be pretty high, so you produce your own body heat. In this case, reptiles, of course, will warm themselves in the sun to warm their blood up. And since that does take place, which it does, that means that their metabolism is going to be much slower. So they don't have to have that. It's not going to be a problem for that blood to mix back and forth. Okay. Are we getting past? Supposedly we're at the peak of the flu season. So how many of you are kind of thinking, I probably could have stayed home, but I'm still going to go? But hopefully we're all past this yet. I think it's pretty easy to say if you look around, especially in the elementary. There's a lot of students gone today, but I think the majority of them are in the elementary. So, what about last week? Yeah, kind of glad we had that 4-day weekend because I was not feeling well. And Friday, Saturday, and Sunday. Finally on the men's yesterday, and here we are. And still maybe not thinking correctly yet because I'm saying endothermic twice. Well, we're about up, down. This is the last cup. This is it. Yes. I don't think so, Tim. Okay. So anyway, moving along. So if this is circulation, what's the difference between the respiration between the two? Which one has to swallow their air? Amphibians or reptiles? Amphibians do. That's why when you see frogs, you'll see that there's a pouch underneath their mouth that continues to move up and down because they're swallowing that air rather than breathing in like that of reptiles. And I believe. Okay, so yeah, we're past that. Oh, all right. So when you had seen that aspect of Nemo, and a lot of you already knew this, which I didn't know it was common knowledge, but when you saw them turtles swimming in that I almost said athletic, Eastern Atlantic current, okay, those turtles can spend so much time underwater because of this structure right here. Some of you had mentioned they can stay underwater for a long time. I don't know which, maybe it was more than, okay, which is essentially, obviously, quite a long time as far as human standards are concerned. Because I don't think you do it much anymore. But for those of you who do go swimming, do you ever try to challenge yourself to see how long you can hold your breath? That's not smart. Was that Brittany Pfefferkorn? Is that what you call that? You're nodding your head yes. Why would you know Brittany Pfefferkorn? The Sandlot, that's right. You know, for those of you who have seen that should be one of them dares you could do. I can picture some of you ding-dongs. So if you come up with the idea, maybe you had it learned from some of the seniors in here. Who could you picture doing that? But you don't wear glasses, though. Do you? But none of you wear glasses. You got to wear glasses because... Oh. Squints! Yeah. Okay. Okay, so let's see here. All right. So, in that second bullet says reptiles use lungs for gas exchange. That's not entirely true for that of the amphibians. So, what is it that these animals do as opposed to that of reptiles? And it's something that we've only made reference to it. What is it when you look at the skin of amphibians? Yeah, amphibians, yep, it's smooth, so air can diffuse across that. Unlike that of the reptiles, then it's tough and scaly because that's no longer needed because their lungs are better developed. Okay, I want to do this one, that one. Okay, we're almost there. And remember we said, talking about the frogs here, unlike amphibians which force air in, and then they swallow that air, okay? So when we look at this, when we're talking about appendages, why would the limbs of reptiles be way more dense than that of the amphibians? So we're talking about their legs, of course, and we're talking about appendages. Why would they be way more dense, do you think? That makes a big difference. Why? You're right. Well, the buoyant force of water will take some pressure off of their joints then. That is correct. And it's one of those aspects to where, as far as rehabilitation is concerned for lower appendage surgery for humans, I think you would already know that that rehabilitation is going to take place in some sort of pool, whether it's just a swimming pool or maybe even a type of whirlpool. And I think I've seen it before. Is there treadmills in pools? Have you ever seen or heard of that before? That'd be a good question for our trainer. Is it Chad? Is that right? Okay. Yeah. So that's one of the things. And of course it makes sense and to do rehabilitation like that. And I'm not saying that Mother Nature gave us that answer. Maybe it did, just because of this here. Just knowing that having that buoyant force take weight off of these limbs would certainly be an advantage, especially just coming out of a surgery. And I don't know how quick that would be, but certainly a structural advantage. Perhaps when they come to Earth, just because their muscle density is going to be a little bit less depending on how long they had spent time in space. That's certainly a very valid point. I do believe it's important for them to continue doing cycling when they're up in space. Otherwise, not putting any weight on your limbs is certainly going to weaken them. That's correct. Okay, so we're gonna get to the lizards, but we'll finish up. We'll talk a little bit about the nervous system tomorrow. And when it comes to the majority of reptiles, especially terrestrial, okay, which means you would exclude the order Crocodilia, which of course is crocodiles, and there's two other sets of animals that are in that order with them, besides crocodiles. Find them in Florida, alligators, and also Australia. Starts with a C. No. I don't know. I think it starts with a C. Caimans, I do believe that starts with a C. So those all would be in the same order of Crocodilia. Turtles, of course, are semi-aquatic, so they would not have this structure well, but lizards certainly do, along with that of snakes. And they do have nostrils for certainly just for having like heat sensing pits, but how do reptiles essentially smell the air? Not with nostrils like this, but yes, there's a tongue-like structure. So we'll talk about that tomorrow. So we'll catch up to you next time.